Welcome to the deep dive. We know there's a constant flood of information out there, so we try to cut through that noise, give you a real shortcut to understanding some pretty complex topics. Today, we're diving deep into something that, well, it quietly powers a massive part of the digital world all around us. Java 8 features.
That's right.
Now, before you think, oh, okay, this is just for programmers, let me just say, this deep dive, it's really for anyone curious about how the software we rely on, every single day evolves, how it gets more powerful, more reliable, and just, well, better behind the scenes.
Absolutely. Java 8, which came out back in March 2014, that was a real landmark moment. It brought some incredibly significant, exciting changes to the Java language itself.
Okay.
And for this deep dive, we've pulled from a really good beginner-friendly summary. We're focusing purely on explaining the concepts, no getting bogged down in code, just, clear understanding.
Right. So our mission here is pretty straightforward. We want to unpack 5 key Java 8 features for you. We're talking Lambda Expressions, the Stream API, default methods and interfaces, the optional class, and the totally new date and time API. And for each one, we'll explain what it is, why it's actually useful, and crucially, how it helps programmers build better, more efficient software. We want to pull out the most important bits of knowledge specifically for you.
Sounds good.
Okay, let's unpack this then, starting with Lambda Expressions. My understanding is these are about simplifying those small specific instructions in a program. But what does that actually look like? Why was it such a big deal?
It was a huge shift, yeah. Huge shift in how you write simple commands. Imagine you want your program to do something really small, really immediate, like sorting a list of names maybe alphabetically, or reacting the instant a user clicks, say, a save button.
Okay, simple tasks.
Simple tasks, exactly. But before Java 8, even for those straightforward actions, you'd have to write out quite a lot of, formal setup code, boilerplate. Almost like, I don't know, writing a whole paragraph just to say hi.
It's very verbose, lots of extra words doing not much.
Precisely, very verbose. Lambdas just cut right through all that. They're a way to write these short, simple instructions without needing all the extra ceremony, all the structure. You're basically just telling the program, here's the little bit of action I want you to do right now.
Oh, okay.
And what's really key here, I think, is how much it reduces the cognitive load for developers, the mental effort.
Right. Less thinking about the structure, more about the task itself.
Exactly. They spend less time worrying about the exact how-to syntax and more time just defining the what. It's kind of like finding a way to write complex ideas in really simple, elegant sentences. It speeds things up and makes the code much easier to read, instantly more understandable.
That makes a lot of sense. Focusing on the core logic, not the boilerplate. Okay. Now, here's where it gets really interesting for me, especially thinking about managing data.
Sure.
Let's move to the Stream API. I sort of picture this helping with, big lists of information, customer names, test scores, that kind of thing. How does it make that easier?
You're absolutely spot on with the big lists idea. Think of the Stream API like a super organized assembly line, but for data.
Okay, an assembly line.
Yeah. You've got your collection of raw items, your list of numbers, names, whatever, and you want to process them in a series of steps. Maybe you filter some out, change others, and then collect the final finished results at the end.
So instead of me manually picking up every single item and figuring out what to do,
Right.
the assembly line just handles the flow.
Exactly. Before Java 8, if you wanted to, say, find all test scores above 80 in a list and then sort them, you'd write this repetitive, often quite slow code that literally told the computer, go item by item, check it, move it if needed. It was like giving your factory worker a detailed checklist for every single nut and bolt. Very tedious. The Stream API lets you just describe what you want to happen to the data step by step in a much clearer way. And the system itself figures out the most efficient how.
So it's smarter about the execution.
Yes, and here's the really clever part. It often allows the computer to work on multiple parts of your data at the same time in parallel without you even having to ask.
Oh, wow.
It's like suddenly having a whole team working on your assembly line instead of just one person makes those big data tasks way faster, especially for large amounts of data. And importantly, it doesn't mess with your original list. It keeps the source data untouched.
So it's more declarative, like telling your GPS, take me home, instead of giving every single turn instruction. You state the goal, it figures out the best route.
That's a great analogy, yes. It shifts towards a more declarative style state. State your intent, let the system handle the optimized execution. It's a huge efficiency gain.
Okay, that's powerful. Now let's talk about something that might sound a bit more technical, but you mentioned it's incredibly practical for updating programs. Default methods in interfaces.
Mm-hmm.
I get that an interface is like a contract or a blueprint. It says what a program must be able to do. Like maybe a vehicle interface says every vehicle needs a start and stop action.
Yeah.
But what did default methods add? Why was that needed?
Right. So before Java 8, those blueprints, those interfaces, they could only list the required tasks. They couldn't provide any instructions for how to actually do them. Just the what, not the how.
Just the
It's
contract.
just the contract. Default methods changed that. They allowed interfaces to actually include pre-written default instructions for some tasks. So programmers wouldn't always have to write that code themselves from scratch for every single implementation.
Ah, okay. So the blueprint could now come with some like standard operating procedures included.
Exactly. And this solved a massive problem, especially for evolving software over time. Imagine a big company creates a core library, something fundamental used by thousands of other applications.
Right, like a shared tool.
Yeah. Now, what if they wanted to add a new required action, a new method, to one of those core interfaces? Without default methods, every single program using that interface would instantly break. They'd all fail to compile.
Oh, chaos.
Total chaos. You'd have to find, update, and redeploy all of them. Think about trying to add a new type of pipe fitting to a city's water main standard. You'd risk breaking connections everywhere.
Yeah, that sounds like a nightmare.
Default methods provide a way out. You can add a new method to an interface, but also provide a default way of doing it right there in the interface. So older programs that don't know about the new method, they just inherit the default behavior and keep working fine.
Ah, so it ensures backward compatibility.
Precisely. It allows libraries and systems to evolve, to add new functionality without causing these huge, costly breaks across the entire ecosystem. It provides stability while enabling progress. It was a very elegant solution to a really thorny problem in software evolution.
That makes sense, avoiding those citywide software plumbing disasters.
Hmm.
Okay, moving on. This next feature sounds like it tackles something really common, avoiding those frustrating program crashes. The optional class.
Yes, optional. This one is all about handling missing information gracefully.
Missing information. You mean like when something's just not there?
Exactly. In programming, we often call that null. A null value means nothing here. And the problem is, if your program expects something like, say, a user's email address, but it gets null instead, and then tries to use that null value,
Crash.
often, yes, crash, or at least an unexpected error. It's like trying to read a book that isn't on the shelf. The program doesn't know what to do. Null pointer exceptions have historically been a huge source of bugs.
Okay, so how does optional help? Is it like a box that might or might not have something in it?
That's a perfect way to think about it. Optional acts like a special container, a box. It either holds a value or it explicitly represents empty. But the key thing is, it forces the programmer to deal with that possibility. You can't just blindly try to use the value inside.
You have to check the box first.
You have to check the box. You have to ask, is there something in here? And if there is, you use it. If not, you have to explicitly define what to do. Instead, maybe use a default value, maybe show an error message, whatever makes sense.
So it forces you to think about the what if it's missing scenario up front.
Exactly. Instead of the program just falling over later, developers are encouraged, really required, to handle missing information proactively. Maybe display no email available instead of crashing the user profile screen.
Right.
What's really neat is how it shifts error handling. It makes it much more proactive, less reactive. You plan for absence, leading to much more predictable, much more stable applications. Less unexpected breakage.
Got it. So basically Java nudging the programmer saying, hey, are you sure that thing exists? Better check. I could see how that prevents a lot of headaches.
Definitely.
Okay, finally, let's talk about something we all deal with constantly, but which apparently is surprisingly complex for computers. The new date and time API. Why did Java 8 need to completely redo something as basic as dates and times?
Yeah, you'd think dates and times would be straightforward, wouldn't you? But oh boy, they are notoriously tricky in programming.
Why is that?
Well, think about time zones, leap years, daylight saving time shifts, different calendar systems, different ways people write dates and times around the world. It gets complicated fast.
Ah, right, all those edge cases.
Exactly. And before Java 8, the built-in Java tools for handling dates and times were, well, let's just say they were confusing, difficult to use correctly, and very prone to subtle errors. Programmers probably tore their hair out trying to reliably calculate, say, the duration between two events across different time zones.
I can imagine the frustration, like trying to measure something precisely with a stretchy ruler.
That's a good way to put it.
Hmm.
The old APIs were often ambiguous or behaved in unexpected ways, so the new date and time API in Java 8 was a complete overhaul, built from the ground up.
To make it less stretchy.
Haha. Yes. To make it clear, consistent, immutable meaning values don't change unexpectedly, and much easier to use correctly for all those common tasks. Scheduling things, tracking deadlines, logging when events happen.
So it handles the complexity for you.
Largely, yes. It provides straightforward classes for concepts like dates, times, durations, time zones, periods. It makes it much, much easier to write programs that deal with time accurately and reliably, handling things like time zone conversions or leap seconds correctly behind the scenes.
Okay.
So whether you're building, I don't know, an international meeting scheduler or just logging when a user logs in, this API ensures that time-related logic is far less likely to have those subtle, hard-to-find bugs. And that's crucial, right? Think about banking systems, flight bookings. They all rely on precise time management.
Definitely. A huge relief for anyone who's ever shown up for an online meeting an hour early or late because of time zone confusion.
Exactly.
Okay, so bringing this all together then, Java 8 sounds like it really marked a significant step forward for the language. It brought in these powerful features, all designed to make programming, well, more straightforward and definitely less error-prone. Just to quickly recap for everyone, we had Lambda Expressions simplifying those small tasks.
Right, the shortcuts.
Then the Stream API, making processing big collections of data way more efficient and readable. That data assembly line idea?
Yep, processing data declaratively.
Default methods in interfaces, adding that crucial flexibility, letting software evolve without breaking everything.
Keeping things compatible.
The optional class, helping prevent those nasty null errors, making programs more robust by forcing checks for missing values.
Proactive error handling.
And finally, the new date and time API, taking the headache out of dealing with all those tricky time-related calculations and making them accurate.
Sorting out time reliably. Exactly. And, while these features might sound a bit advanced if you're maybe newer to programming, they were genuinely designed to smooth out the coding journey, to hide a lot of the old complexity and ultimately make the software that gets built using Java much more robust, much more reliable, really, for everyone who ends up using it.
Yeah, that makes sense. It benefits the end user, too, even if they don't know why the app is more stable or the times are correct. So what does this all mean for you listening right now? Maybe consider how these seemingly abstract changes deep inside a programming language, how they directly contribute to the smoother, more reliable, maybe more intuitive digital experiences you have every single day. From a mobile app that maybe doesn't crash when your internet connection flickers, to that flight booking system that actually gets the time zones right. These under-the-hood innovations, they're constantly improving the digital world around us.
Yeah.
So here's a thought to leave you with. What other invisible improvements do you think are making your tech experience better, perhaps without you even realizing it?